Okay, we'll pretend we just started. Okay. Okay, so no. The one reason I wanted to start recording is because I know I have a screencast already there, but I changed a couple problems in the notes this year, but they're not until the end. So T for trapezoid. Okay, now remember. Okay. So h over 2 base 1 plus base 2. I'm going to write it out the long way, and then I'll show you how we can.
Wait, why is it h over 2? Wait.
This is the formula for the area of one trapezoid. Okay?
Oh, right, yeah.
Right? So now we want to do 4 trapezoids. Okay, so we have h over 2, so 1 over 2. Base 1. So remember, I'm plugging the bases, I'm plugging in the endpoints into the function. So base 1 is 1 over 1, base 2 is 1 over 2. Right? Plugging into 1 over x. Okay. Next one. Well, the height from 2 to 3 is still 1 over 2. Plug in 2. I have base 1 is a half. Plug in 3. Base 2 is 1/3. Okay, so I took care of the second one. Next one's going to be same height, h over 2. Base 1 is 1/3. Base 2 is 1/4. Took care of the third one. Last one, same height, 1 over 2. Base 1 is 1/4. Base 2 is 1/5. Okay, so that's a lot of computation. We can actually abbreviate this quite a bit. We could have 1/2. And what do we notice? What do we notice? The 1/2 is used twice. The 1/3 is used twice. The 1/4 is used twice. Remember when I was showing you, like if we look at this, this is used twice, this is used twice, this is used twice. The ones on the end only used one time. So I could just put like this. It's just less work to plug all into your calculator, right? You just added them?
Oh, I guess
I mean, okay, below is the shortcut, okay? So this is our trapezoidal approximation.
Oh, there's a shortcut. So
This is the shortcut.
that was the shortcut?
Doesn't this one look a little less writing? I mean, maybe not a lot, but a little bit. Okay, I'll tell you we get 1.683. Okay, so that's basically, why is this up here? Our trapezoidal rule. H over 2. Notice the first and the last are used once. All the ones in the middle are used twice.
Oh, that was the shortcut.
That was the shortcut. I already showed it to you. The only time we could use this, though, is if the subintervals are of equal length. H is b minus a over n. Also, trapezoidal is the average of LRAM and RRAM. Yeah.
Like, if all the E's are the same, right?
If all the H's are the same.
That's
If all the H's are the
so
same.
H.
Like here.
Yeah,
all
that's
the
what I
H's.
meant.
Yeah. Yes, base. I understand what you mean. Okay. All right, let's graph square root of 2x from 0 to 8. Oh, come on, we can do this, right?
Yeah, just so much.
Okay, come on. Plug in 0, we get 0. Now, I'm not going to plug in 1 because I'll get square root of 2, but if I plug in 2, I get 2. The next one that will result in a perfect square, 8. If I plug in 8, I get
If you plug in
4.
0.5, you get 1.
Yeah. So, again, it doesn't have to be perfect. I'm not looking for a perfect graph. It's how you estimate the area under that graph that I'm concerned about. So here's my region. Now this time I have the interval goes from 0 to 8, but I have 4 sub-intervals. That means H is going to be 2 units in length. So I'm going to have one here, 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 and here. And now, do you see why, again, we use the trapezoid? It's a much better approximation. Okay, H over 2. 2 over 2.
Wouldn't the first one be better if it was like a triangle?
So technically this will be a triangle when I plug it in.
See, yeah. That's not a triangle.
Okay, so I'm going to plug in, I'm going to show plugging it in just so you can see it. So square root of 2 times 0 is used once. Okay, now 2, 4, and 6, when I plug in, are used twice. So that's why I put the 2 parentheses. So the next one's going to be square root of 2 times 2, square root of 2 times 3, square root of 2 times 6, and the last one, square root of 2 times 8, is used one time. Now I realize you can simplify. I just wanted to show we're plugging all those endpoints in. First
Why
and
is it not 4? 2 times 3.
oh, that should be 4. I'm sorry. That was a mistake. Okay. All right, now let's simplify this. Okay, well this is just 1, so that's not going to change anything. This is 0. So I have 2 times 2 plus 2 root 2 plus 2 root 3 plus 4.
I still don't get it, but it's okay. I'm sure.
Well,
I don't get the middle.
the
What's
middle?
going on there?
Because this one, and this
I
one.
get it. That was a really good explanation.
Wow. Thanks.
It just clicked.
Wow.
While you were speaking.
Okay. All right, what do we get
It
for...
wasn't personal.
So this is like neither algorithm
Well, it's
This is trapezoid, not.
or like the other
It's
ones have
the-
to do with the others.
It's the average of LRAM and RRAM.
Okay, listen.
It's LRAM and
Yeah, is that
plus
not
RRAM. And
No, midpoint is different. You want to know why? Midpoint is using a completely different value. LRAM uses all the left endpoints. RRAM uses the right endpoints. If we added them all together and divided by 2, that would be trapezoidal.
Wouldn't it be 8 plus 4 square root over 2?
Oh, yes, thank you for catching. Sorry, guys. Yeah, of course, that should be 4. I forgot to distribute. 4 plus 4 should give us 8. 4. My mistake.
Wait, so it should be 4. Oh, wait, never mind.
The decimal is correct, though.
Wait,
Oh.
Thank you. Wait, is that a 9 or a 5? It's 25. It's 25.
Why is there a Aiden?
Yeah, I'm a shoe right away.
Okay.
I know, I was balling out.
God knows.
I got no minutes.
All right. One more of these, and then we'll do some tables.
He's a
Yeah, they were no.
I said it was a graduate.
He was
but I don't
he
remember.
said, Coach said it was balling out.
What was it?
Oh.
He was definitely
He was 20. He's class of 20.
Yeah.
He's old.
Oh my god, this makes sense.
Thanks.
No, you're young.
Oh,
You look
I graduated in like. Okay. Let's graph this. Okay, we got negative x squared plus 4 from 0 to 2. Okay, so 0. We get 4. 1 we get 3, 2, 0.
Those are
Why is there no graph?
What?
Those are graph. Yeah.
I mean,
I just went from 4 and I did like
okay. Here at a minimum,
make sure it ends at the end. Okay, that's what I
at a minimum, plug in your endpoints. Right? Like if I plug in 0, I get 4. If I plug in 2, I get 0. And you hopefully can see it's an upside down parabola or part of it.
That's why.
So that's okay. That's okay. I technically didn't really need this extra point here.
Wait, how did you find that thing? Like in one? But then isn't that?
If I plug in 1, I get 3.
So then it's on YouTube.
What is going on?
Oh.
Okay. Now,
I don't see how to make a trap song.
No.
No, it's a triangle.
okay, my height is going to be what?
Your height.
It's going to be a half.
You're so new.
Because you do 2 minus 0.
I see the vision. I don't know.
Okay. Listen. It's nice and evenly distributed, so I can do 1/2 over 2. Okay. H over 2. Okay. The first and the last are used 1 time. So if I plug in 0, I get 4. Okay. Now, 1/2, 1, and 3/2 are used twice because those are inside bases. So if I plug in a half, okay, so that'll be 1/4.
Whoa, wait, it's the negative.
The negative's on the outside. So negative 1/4 plus 4.
Obviously.
We could do it. Come on, we got this.
Wait, I'm getting
Use your calculator. You can use your calculator too.
3.
If I plug in 1, that would be negative 1 plus 4, 3. Okay.
9 now what? This is challenging math.
9/4. Negative 9/4 plus 4.
That's minus 2 and then a little 7.
7/4, which is 1 point.
Wait,
1.7.
1.75.
Oh, wait, I'm sorry.
Yes, they did.
Okay, and the last one is 0. Technically, the last one doesn't even really exist, but I just wanted to put it in there.
If it was above 0, what's the answer?
Okay, to save you some time, we get 5.25.
No.
I'm so proud of you.
Okay, I actually get this. We can
Okay.
solve it. We can do it.
Now it gets easier with the tables.
So the outside ones are only used once. I already get it.
Okay,
How did you do it?
what is H here?
Ow.
1.
Yeah.
Okay.
Wait, but how do we know the equation? How do we know the
It's even easier.
No, yeah, you're right. It's just by how much is
Not
Yes.
I forgot, yes. Okay, so 10 is used once. 16, 18, 20, 14 are used twice. And the 10 on the end is used once. Of course, we noticed 10 shows up twice. If you really wanted to, you could.
Wait, so 10 is used twice.
Why is it not 5 over
Why
2?
is H?
So everything's used twice now.
Okay, hold on. I got several questions. The height is 1, because remember,
I want everything.
5 minus 0 divided by 5 sub-intervals would be 1. And also, if you just look, right, The subinterval length is h. So again, this one used once. And these are all used twice.
Wait, I'm gonna do it. 34, 54,
We're going to do this by hand.
68, times 2, 136. Times 2 again. Yes. No. 156 divided by 2. 70.
Whoa. Okay.
Alright, never do my constant. No, I need it.
Okay, now, so far the last few problems were lovely because it was nice and evenly distributed, but it's not always, just like we had rectangular approximation. So now we have to do each separate trapezoid. It's not hard, it's just a little tedious. So if we look at,
I like that. Ow.
okay, the first height is 2. So 2 over 2, base 1 plus base 2.
Can I like combine?
Listen, you could do some combining. I will tell you, don't do that. Like when you write out the trapezoidal rule on the AP exam or on my test, I want to see it all written out. Okay, don't try to combine.
Wait, but I have a
So
question.
now, yeah.
Wouldn't you be able to include the 8 and the 10 also in this if it goes up too?
That's what she's.
I'm gonna use all of them as separate. So the first trapezoid goes from 0 to 2. That's my height over 2. Base 1 plus base 2.
Yeah, I was just asking because from 8 to 10 it's also 2. So
Yeah,
it's
that's
just like
yeah.
addable.
Yeah.
So
Don't.
it's hard. Don't do that.
So 1 over 2. I want you to show, and on the AP exam, they're gonna want you to show this. Next one goes from 3 to 6. Well, from 2 to 3. 2 to 3 had a height of 1. H over 2. Base 1 plus base 2.
I always forget H.
Okay, H. So from 3 to 6, it's 3. 11. Do you get the idea now? Okay, so 6 to 8. 2 over 2. 15 plus 12. And last, we have 2 over 2, 12 plus 10.
I got this. Stop, I got this. 13 plus. Come on. 39? Okay. Is that the answer?
What about 39 too?
Wait,
Oh, 7.5. Oh, wow. Look at that. That's a lot. Don't say it out loud.
Don't say it out loud. You would not be asked to do this by hand.
Are there second comedy because
128. No!
2/3 of the test is without a calculator.
15 over 2.
Wait,
That's
our next
like
what's
the
our
essay.
1/2. That would be 1 of
Are these
7.5.
harder now?
It's 1 of 7.5.
Yeah.
And wouldn't it be
Yeah.
1 of 6.5?
What? Yeah.
I think we're missing times.
32. No. This. Yep. 3. I got 2.
Okay. We got 2 application problems here. Sorry to say they are also not evenly distributed. Okay? So we're measuring temperatures from noon until midnight at different times. Okay? We want to figure out what's the average temperature for the 12-hour period. Now, normally, if this was all nice and evenly distributed, we could just add them and divide by 12 hours. But I don't know what's going on at 2 o'clock or 5 o'clock or 7 or 8 o'clock. Okay? So what we're going to do is we're going to do trapezoidal approximation to come up with the total accumulation of all of those temperatures, and then we could divide 12. Because we want the whole thing.
Why does it say N?
So noon, we're going to count as 0. So noon is 0. Midnight is, right? So let's just do the trapezoidal and then we'll figure out the average. So our first height is 1. Right? It's exactly what we just did.
Wait, was there any more to it?
Well, so what this is going to do is figure out the total of all the temperatures
And then
added
you divide it
together.
by 12?
Then we divide it by, because we want the average over the 12. Not quite enough space, kind of.
I ran out of room.
Yeah. Sorry.
I'm just gonna trust you.
You're just going to trust me here? Okay.
Get it?
When we add all this up, 782. Okay. Okay, now I want to know. So this is the total accumulation of all the temperatures. So if I just want the average, so our,
So why couldn't we have just added all of them? And then divided by 12? Oh, because that's only the average of those.
correct.
Not like
It's not taking into account what's, if I were to add these and divide by 12, that's not going to work. If I add these and I divide by 8, that's also not going to be accurate. So we get what? 65.167 degrees. Okay, good. All right, last one. If we can make it through this. Can we make it through it? Okay, we had something similar to this with
Where you don't
rectangular.
count the first one and the last one.
Okay, but so now we're using trapezoids to approximate. We want to do 2 things. I want you to find the total distance traveled and the average velocity. And notice this is similar to one that you had where velocity is in miles per hour. The time is in seconds. I'll deal with the units later. Let's just do the trapezoidal.
I don't get. I have a question.
Yes.
Why the average velocity? You don't just add it all up and then divide it by how much there is. How-
But again, the times are not equal.
The times are not even. The times aren't even.
Alright.
So basically it's saying, right, like it's like some of the times might be weighted more heavily because this, I skipped from 0 to 3.
It's saying from 0 to 20.
But then I have like 6, we have to make sure that if I were to graph this, like I could technically plot these points. At 0, I have 13. And then at 3, I have 27. And then, so basically what it's doing, right, and then it goes up here. So I'm basically making a bunch of trapezoids to estimate that area under the curve. Okay. So, yeah, the units in this one is really kind of weird.
I get it. Please let it happen.
Are we going to try to do this without a calculator again?
That's miles. That's just miles. How did you get over 2? Oh, yeah, it's over 2. It's over 2.
All of them are.
Want to divide by the 27.
This by.
Ooh.
27 miles per hour. Well, not by
This is like
then you
meant
get
for
miles per
careless
second.
mistake.
I know.
Oh, I did it. No, you don't.
Yeah, miles per second. So I converted seconds into miles.
Okay.
Yeah. So then miles per second.
Okay. All right, you get the idea here. We get 858. Okay, now, this is kind of a weird unit like we looked at yesterday. Remember the whole distance equals rate times time? Right? Well, if my rate, so is going to be in miles per hour, and I'm multiplying it by something in seconds, this unit doesn't really make sense. Okay, it's like miles times seconds over hour. So remember what we did yesterday? We converted this. We divided.
3600.
Okay, so the total distance is going to be 858 divided by 3600, which gives us 0.238 miles. If I want to change that to feet, we can multiply it by 5,280. It's fine if we leave it. Okay, now I want to know what is the average velocity over the 20 seconds.
Do you divide 850
There's a
by
couple.
20?
Yeah.
42.
Ooh.
No, please
Okay, so why do I just have to take that and divide by 20?
It's like what he was trying to say.
Because you're skipping values.
Yeah. I mean, listen, if I took 0.238 and divided by 20, that would be miles per second. I don't want to measure anything in miles per second. So then if I did that, I'd have to multiply by 3,600 to turn it back into miles per hour. Well, it's much easier just to work with this and divide by the 20. Then I don't have to switch it back and forth.
Yeah.